So our third speaker this morning is Dr. Michael Santiago. Michael received his PhD from Cornell University, and he's founder and CEO of FloraPulse. And we're going to hear some talk about, with an incredibly interesting title, Should I Irrigate? Ask the Tree. Implantable MEMS to measure plant hydration. So Michael, thank you for joining us, and we look forward to your presentation.
All right, sounds good. Can you guys hear me okay? See the screen?
Yes.
Awesome. Well, yeah, so I'm Michael, FloraPulse. And yeah, just really excited to talk about a few things here and there. We'll try to keep it mostly short because of time. But, you know, we all, I mean, the first speaker was like spot on, right? The agriculture is very important. I mean, it's basically, it's what the basis of civilization, really, being able to grow food for an increasing amount of people. And then water is extremely important, not just in agriculture, but in other places as well. And, you know, California, I'm living in California these days, and the drought just keeps getting worse and worse. And when we talk to customers in other places, in other parts of the world, there's drought in a lot of different places like Australia and South Africa, so on and so forth. So, and it's just only gonna keep getting worse, right? There's a bit more climate change, that sort of thing. So it's very important that we handle this issue. And from a different perspective, just going towards the agriculture part, we've calculated about $100 billion worth of fruits and nuts is lost every year because of poor irrigation decisions. But you know, we're putting an end to that. It's my statement. And so what we've developed in a kind of a broad sense over 15 years, I'll go into the story a little bit, is a water potential sensor that goes directly in the trunk of the tree. And so it measures the thirst or the need for water directly inside the tree or the plant. And so this can give the grower the most accurate information of exactly when and how much to irrigate. This is really a real breakthrough. And, you know, I'll start into the business side of things a little bit, and then we'll go into the technology. I think it's really important when you're developing something to have it, you know, you're developing a technology, but it has to be with a specific use case in mind of the actual customer, the actual face of people that you're working for. So, you know, our sensors, we're showing that they can really help the vineyards, for instance, save water and improve the quality of the wine. Water savings are great from an environmental standpoint, but from an economic standpoint, it's really important to increase the revenue or the profitability of the grower. And so if you know about red wines, you know the best wines are grown in dry regions, and that's because the vines are water stressed. So places like Bordeaux and Napa Valley have very high water stress. So, you know, the vines are thirsty, and that produces the aromas that people associate with high quality wine. So it's very important. Now, in a different sense, we also work with orchards, and so what's water status is very important for the yield of the tree. So you need to keep the trees happy, and so you need to be able to irrigate at the right timing to be able to get good results. And it's funny because growers that we worked with, this one grower, for instance, he lost 2 years of production because he was over irrigating his trees. His trees looked sad, so he kept putting water on it. And what we found out very quickly is that he was actually putting too much water on them, which was making them look like that. And so it's a very difficult problem to know exactly when's the time to irrigate. And so we've seen, as I'll show, growers having some pretty good results. Here's a testimonial of somebody that we worked with, where they have a prune orchard, and this is actually quite amazing. He was able to make like 15% increase in yield, which translated to thousands and thousands of dollars because of better irrigation, right? So this is a problem the growers are having, but they're not really, they might not see it. So, you know, you also got to save water, increase the fruit size and yields, so on and so forth. So now that the business side is, you know, kind of out there a little bit, I want to talk about the story behind this. So this will give you a sense of how long these things take. The original idea for this came out in 2007, I believe, 2006, when Abraham Strook and Alan Laxo, professors from Cornell, got together and came up with the original idea. I joined the project in about 2012, so I've been involved in this for about 10 years now. And we went through a number of different iterations. Initially, a lot of it was developing the microchip, but then there's been other challenges as well. And so, just going back to into the science a little bit, water potential is you could just say it's the water stress, the water status of the plant, and it's very important. It really determines, as I mentioned, for example, here you can see on the left side here, it can determine the weight of the berries, the sugar level. There's some research done on the plant survival as well, yields, and for wine connoisseurs, it affects the quality of the grapes and the wine. And in a broader sense, it is the driving force. So gradients in water potential, right? The differences in water potential is what drives flow of water. And that is how plants actually transfer water from the soil into the atmosphere. They pull it through the roots all the way, and so then it goes through their xylem, their wood, and the leaves, and then finally into the atmosphere. So it's a very, very important quantity. It's also really difficult to measure. And the physics of it is just that the liquid is under negative pressure, which requires very different sensing mechanisms. And so how this began, right? It just kind of came about. The Stroop group developed what he calls artificial xylem. He had the idea of wanting to communicate with plants, be able to talk to plants. And so this was the first idea to make an artificial plant, right? And so this was done actually in the CNF, cleaner by Cornell. And so they kind of showed some of the same dynamics that you would see in plants in the field when you kind of expose them to water stress. And so then from there, what ended up being developed over time, it's like, hey, if we can model how plants work in the lab, maybe we can actually use this to measure the water status of plants. And so this is what ended up being developed. It's a microchip tensiometer. Tensiometer measures water status, but what we did is we were able to shrink it down to be built into a microchip, which has a lot of advantages. I mean, one of them being clearly cost, right? So you can build microchips for way, way cheaper than it would take to build a whole probe. But then also some advantages with that is that you can actually put it in different places and so on and so forth. Not to go into too much detail about this, but here's just like one of the older versions of the chip. Right, and the top side just has a pressure diaphragm. Bottom side just has a little bit of water, so it kind of acts like a tree where it has a little bit of water in it, and then exchanges water with the tree. And so a big challenge was developing this first version of my little microchip. But then beyond that, it's been kind of, you have a chip, then how do you make it work in the field, and how do you go from there, right? So developing the original technology, it's all fine and dandy, but then beyond that, there's a huge number of challenges that you just find out as you go. And so, in any case, this chip exchanges water with the environment. So there's just kind of the sample. So if you put it inside of the trunk of a tree, it will measure the water status in it. We just kind of here, I'm just showing it was packaged into something that could be inserted into a tree, a plant, the soil, etc. Not to go into detail here, but I just figured I'd show some microfab process flow. This is kind of a simplified way of doing it. The real breakthrough that allowed a lot of this was the developing of a porosilicon process, which is like these nanopores that we can etch directly into the silicon. And this is what allows us to mimic how plants transport water, because plants transport water through a network of pores that are interconnected but you kind of need nanopores and macropores together. So with this, we were actually able to mimic basically how plants transport water. So this was the breakthrough that allowed everything else to happen. And then so we have a chip and everything, that's great. Then how do you reliably put it into a tree and have it measure. And so as we talked about agriculture, right, the challenge is it's substantially easier to make something that's a proof of concept and test it in the lab and then say, yeah, it works for a couple of days or whatever. But when you're trying to sell something to a grower, as it was mentioned before, price is very important, and then reliability is huge as well. So the challenge goes from developing something that kind of works, making something that works reliably in all sorts of different environments. And so just just to give you a little bit of a sense of the issues that are always in this sort of thing, we had to work with you're putting something into the tree, so we had to deal with like the wounding response to the plant, how to consistently access the water transfer tissue, because there's other tissues in the plant, how to get a good long-term seal. We got some issues with temperature as well. So lots of challenges. Thankfully, over the course of a few years, we've been able to figure out all these things. So it's been quite the experience. I'm not gonna go into detail here, but this is just kind of how the sensor is installed. So I figured it'd be kind of fun for you guys to see this, right? So it's all kind of held in place by this metal sleeve that gets hammered into the tree. Then we drill into it. There's some compound that goes into the tree to help it make the sensor make contact, and then the sensor goes into the tree, so it kind of gets inserted there. And then finally, you have a logger that communicates. And so, what do we find from this, right? So I just think this is really great. We can see the heartbeat of the plant, right? Like just like humans have a pulse about every second or so, your heartbeat goes up and down. Well, plants have a pulse, but it takes about a day. So if you look over here during the morning around 6 a.m., the water potential, this is the highest water status of the tree. And then during the day, it kind of goes to its lowest point. This happens around like 2, 3, 4 p.m. As the sun comes out and it starts transpiring water. And then it recovers during the night again to go up. And so this is something that it has been extremely difficult to get until we came along. So we're able to measure continuously this heartbeat of the tree. And then going beyond there, we started doing some testing, and it was pretty clear. We found out that growers tend to both over irrigate and under irrigate. So for instance, here, this is just kind of a measure of the water status of the plant. And just from previous research, we know that there's an ideal level of water status for plants. And what we found out is that, that if the grower was irrigating correctly, right, they would keep the tree basically in the green area. But what we were seeing is that they were really going into the red, sometimes really, really dry for quite a while, which is well known to dramatically decrease your yields and crop quality, crop health. But the problem is that they lack the information. So again, with this, we can really help them out with that. And another thing that we found out is that even if you're measuring the tree, there's a way to measure it manually. Even if you're going out there and checking up on the tree, if over the course of a few days, your tree can go from fully hydrated to just a huge crash to very, very dry, very thirsty, which again will have big consequences. So now going back to the business side of things, we've the goal has been to develop this into a fully fledged product, and we've been successful with that so far. So we developed the microchip right into something that can actually be sold to the grower. We have this built a little box. You can ship it to the grower. They can install the sensor themselves into almond trees, walnut, grape, etc. And then they get the data automatically in their phone, which gives them recommendations, that sort of thing. And the advantage that this has over everything else that's out there is that it is automated and accurate. So everything else out there basically is either it's accurate, but it's just very difficult to do because you have to send somebody out there to take these measurements manually. It's a huge pain. And there's just a lot of like really good technology out there that measures things indirectly. So they might look at the atmosphere, the soil. And so there you're really lacking that measurement that needs to happen in the tree itself. So just kind of some track record with our product is being sold in 12 countries. We're working with about 40 companies or so, 4 international distributors. So we're getting, and product was launched last year. We're getting some really good adoption from people. They seem to be really excited about this. So this is looking pretty good for us. And then, just kind of I always want to think about like what is the impact, right? Like how because I think that, at least from a business perspective, right, as a scientist, the focus tends to be always on like, okay, what's the technology and like how do we develop technology? But you really have to look broader than that of like, what are we trying to accomplish? How is this going to help the grower, and how does it fit within what the growers are doing, that sort of thing. And so, just to give you guys a sense, I think over the next, few years, we can help say, once this becomes larger and larger scale, we're going to help save a lot of water, increase the revenue of the growers. This is just in California, and make even better red wine, which I'm a fan of. So we have a company with a big potential impact, right? So the water stress is it's huge for agriculture, right? And it's becoming a really big problem worldwide. And so we think we can have a big impact on the bottom line of the growers with a solution that's scalable and low cost that can really go worldwide. And so, I mean, with this, yeah, I'll just take some questions. We are looking for like growers to work with, investors, that sort of thing. So if you're interested, let's talk. But otherwise, I'll cut it short. Get some questions from the audience.
Wonderful. Thank you, Michael, for a very interesting talk, and also I think giving us an appreciation of the real world problems that one has to solve. When you've come up with the sensor, your job is just beginning, I guess, would be one of the things that I learned. Let me ask if there are any questions first from the audience. I have some, but you're probably tired of hearing my questions. Please raise your hand, or even, well, I don't know if chiming in is possible, but please raise your hand if you have a question, and Pat and Tori will
Physical hand?
Yes, please, go ahead.
Yeah, so Michael, that was wonderful. What you described for embedding the sensor in a plant implies you can only work with plants that have woody stems. What do you want to do with, I'm going to call them softer crops? Like, what if you wanted to track corn in the field, or something like that? Have you begun to think about that?
Absolutely. So we actually have that's a good question. So yes, we have. It's the woody plants was an easier target, so we started out with that. We're actually writing a proposal to work on to develop something for smaller crops, have smaller stems. We have a way that it could be installed in these smaller crops. And so that is ongoing. And regarding to like corn, yes, it's a possibility. It's a bit, the business case is a little bit harder, because for a tree, for instance, you can put this in and it can stay there for multiple years. Whereas in corn, it is replanted every single year. So if you're putting it out there, you'd have to reinstall it with all the costs that come along with that every single year. But yes, that's because we've got an interest from corn, blueberries, cannabis, for instance. So yeah, so there's some work being done on that.
And I see you mentioned better wine, so I'll just make a pitch that Ithaca's in the Finger Lakes wine district. It's not just in California. There's actually good wines closer.
Absolutely. I agree completely. You guys have some of the best Rieslings and Chardonnays.
Michael, I have a question. So, for the different types of wines that you guys are, or the vines that you're looking at, is there different trigger points to when that tells you when to actually irrigate and not irrigate? I mean, I imagine different varieties have different needs, correct?
Yeah, absolutely. So yeah, that's it. The answer is yes, but it's very very complex. I mean, but overall, in a big sense, the white wines, you don't want to stress them, so you generally keep them pretty well hydrated. So that works really well for New York, for instance, because you guys get a lot of rain over there. But then the red wines, depending on, again, some of them, the Cabernets, you can really stress them a lot. So it depends. Yeah, Pinot Noir is a little bit different, and so these are guidelines that the growers themselves have, but it really depends on the winemakers. The winemaker, the vineyard managers really get to decide what characteristics they want in their wine, and so then they will decide to stress them more or less at different stages of growth. So yeah, and it's fascinating. I mean, the people have been studying this for since hundreds of years now. So yeah.
Christian, did you have your hand up?
Well, my question just had been answered, so yeah, thank you.
That was, I think, also my question, which was you showed this beautiful chart of keep the water pressure within this certain range. How did you figure out what that range is? And I think the answer is many years of experience from many different vintners contributing to that correlation, perhaps.
Yeah, so I mean so we have one advantage that we have is that if I go back to, well, anyways, so we're kind of replacing this manual instrument. I forget what that was. Well, we're replacing this manual instrument that is accurate but just very difficult to use, and it's this one on the left side. And so that has the advantage that we give the same data as that instrument. So the data, people already know what it looks like and what to do with it. It's just really difficult to acquire currently. And so there's been a lot of studies that people have done using this pressure chamber instrument over the last 30, 40 years. So we're just kind of building on top of that.
So I'm thinking this is fascinating, and I think shows the potential of using these nano-enabled things in agriculture. And I think the system you've developed is a great example of something that starts all the way at the nanoscale with the microfluidics and moves all the way up to the communication scale to get this information where it needs to be.